Hi, and welcome back to the Low Level Devil Channel's Raspberry Pi Bare Metal series. In the previous video we covered the VideoCore Mailbox Properties API. In this video we're going to use that API to create frame buffers so we can draw to the HDMI output. So let's get started. Actually, I also want to mention really quickly that I did set up a Discord channel as some people have requested. So it's a place that you can discuss some of these videos or things related to them and all that. I'll put a link in the description. I'll see if I can figure out how to put a link on this video as well. Okay, I'm going to start by adding a new header file. So this will be our video.h header file. It'll have the functions that we'll want to call from the kernel.c file. So we'll start by using the pragma once, and then a few headers we need to add. Common. Actually, yeah, we can just leave it at common. So the first one we're going to create is a video set resolution, and that will take in the X resolution, the Y resolution, and bits per pixel. Okay, and let's see, next we need to create the video set video draw char, and that will take in a character, a pause X, and a pause Y, which is where we want to draw a character on the screen. And then again we'll use the video draw string to draw those characters, because you don't want to do one at a time. And pretty much the same interface, except it takes the string instead of just a simple character. Okay, now we need a couple of helper functions that video header is going to need. Font get height, font get width. Actually, these are, I'll just put a comment here that these are going to come from the font data.c. which I'll create here. And I'm just going to paste this in. This actually comes from some Linux code, so I'm not going to really go over it in depth because it's not really that important for this video. But you can see it's for the Latin 16 console from this KBD keyboard and font utilities package by these people. They're the original developers of it, and it's essentially a gigantic char array that has all the pixel data for the Latin 1.16 console font. Alright, so I'll have this on the GitHub, so if you want to look at it there in depth, but there's not really much for me to explain here. I'll run through it here real quick so you can see what it contains. And that's what we'll use to actually draw these pixels from a font. So I'm going to grab that function there, font. Let's see, was it? Yeah, font get pixel, that takes a character, the XY position of that character to determine whether a pixel exists on the font at that point. Alright, so now I'm going to create the video.c. This is where we're going to actually implement the video initialization and setting the resolution and all that. Start by including the mailbox header, the printf header, timer so we can do some timing on it, and our video.h. So I'm going to start by creating some structures here. The first one's going to be the mailbox frame buffer size, and this is going to be one of those mailbox tags. So we have the tag at the beginning, and then two properties, an XRes and a YRes. Now if you remember the definition for this, we have the mailbox tag, which is used in, for instance, a mailbox generic command. So if you haven't watched the previous video, you really want to understand this, so you'll want to watch that video as well. So now we're going to create a couple of more structures that are needed to create a frame buffer. Let's see. I'm just going to copy this. So we have the, again, mailbox tag. And remember, they all have to start with that. And this is going to be the bits per pixel, so this is going to be the mailbox frame buffer depth. Okay, so on this next one we're going to have the pitch, which we'll call mailbox frame buffer pitch. And this one will be the actual buffer, so it'll have the base, which is going to be the base address for the video buffer, and then the screen size, so it'll return the actual number of pixels essentially that are on the screen, or the I believe that's the size of the full buffer if I remember correctly. We don't actually use that, but it's in the API. So now I'm going to create a structure that actually contains these structures, and we're going to send this in one big chunk to the mailbox instead of one at a time. So we're going to have this res, and we're also going to have a virtual res, which you can set a virtual resolution and then a physical resolution. I'm just going to stick with them both being the same size for now, but you can experiment with it. So after those two resolutions comes the depth, and then the buffer, followed by the pitch. And we'll call this the mailbox frame buffer request. Alright, now that we have the essential structures for this, I'm also going to take this request and just make it a static variable so I can reference it in other functions here. So we'll start by creating the set resolution. So it'll be the full video set resolution, taking the X res, the Y res, bits per pixel. So now I'm going to create this request object. Actually, we didn't need that request object, but so the frame buffer request res tag ID. So this is going to be RPi firmware. Let's see, it's frame buffer set physical width height. It's a nice long variable name, or not variable but constant. So that's the tag ID. In the buffer size for this is going to be 8, because we're giving it 8 bytes total, or yeah, bytes total. And the value length is also going to be 8. So it's going to actually return the value that it set it to as a response. So let's see, X-res and Y-res to the values passed in. So that's the first structure in the frame buffer request. And the second one's really similar, so I'm just going to copy and paste that. Change this physical to virtual, and that's pretty much all it's needed for the second one. Yep, everything in, oh yeah, we need to change this to VRes, can't forget that. Alright, so now I'm pasting this again just as a start. So now we want the depth. I'll take depth, 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 depth. This last one we won't need. And the depth has bits per pixel, BPP. I want to set that to the value passed in. And let's see, this is going to be frame buffer set depth. And the buffer size is only going to be 4, because it's only a 32-bit number, and the length as well. After the depth, again, comes that buffer. So this one will be buff, buffer allocate. And this one is going to be, so the buffer size is going to be 8. We're passing in 8, and the value length is only going to be 4 because the value that we're passing in is only this very first base value, and then the buff dot screen size, we don't actually pass that in, but it will come back in the buffer. So it'll have a valid value once we call the mailbox process function. So let's do one more of these, and this is going to be the pitch. Yes, pitch. Okay, so we can just type pitch there, copy, paste through here, and it should be just pitch, yeah. And the pitch we're going to set to 0 because that's going to be not a set, it's going to be a get. Yeah, I typed this wrong, hold on. So that should be get pitch. So essentially it's going to call all 5 of these commands at the same time and then return the data back in the structure that we're passing it. So we're going to make a call to that mailbox process function. Cast this to mailbox tag. Size of FB request. So at that point the actual resolution will be set. So if we can actually print out the location of that buffer, that'll be the pointer for it. And the size, we can print that out too. So buff.base and buff.screen size. So we'll just print that out to the console like we usually do. Then I'm going to sleep for a couple seconds and before I start actually drawing stuff on the screen. So this section is the sets the actual resolution. And then down here we're going to actually draw a red square with a blue boundary. So we'll say draw a blue box with a red box inside it on the screen. Actually, before that too, I think we want to print out what the resolution is, so we'll draw some characters. So we'll draw some text showing what resolution is set. So let's create a string here, sprintf resolution %d by %d. No need for a return there. So we're just going to write this to the screen. Alright, x res and y res, and we'll call that video draw string. Pass in res, and we'll put it in the upper left corner, so 2020. So we got a little bit of a border on it. So it's 20 characters to the right of the left and 20 characters down. So now let's start working on drawing this screen contents. So first we'll start with the square margin. So the margin around the red square, I'm going to say 100 pixels. And you can play around with different values for this, you know. You're going to use this on your own thing anyway. So now we have the start milliseconds because I want to time it and see how long it actually takes to draw this screen, because we're not using the GPU here, we're actually going to be drawing to the memory directly with the CPU. Alright, so and then for and y res. So now for each on the y coordinate, Now once we get to the coordinate 40, then we're going to actually redraw that text at the top because we would have drawn over top of it. So I'm just going to draw it again so we have it still there so you can see it. And I'll say just the same thing, video drawstring, res 2020. So now inside of our while loop, we're going to loop for each x as well. Now we need to get the pixel offset, and the calculation for this is the x times 32 shifted over by 3 plus y times the depth, or the pitch. So req dot pitch. Yeah, there we go. So that will be the pixel offset for that x and y coordinate. So the pixel offset in the frame buffer. Remember, the frame buffer is going to be a big chunk of memory. So now I'm just going to put a bool here. Am I drawing the square or am I not drawing the square? So if I'm drawing the square, I'm drawing the red square in the center. Otherwise, I'm drawing the blue margin. This is going to be just a simple y is greater than the square margin, and y res minus y is greater than the square margin. So we check the y size. And we'll do the same thing for x essentially. So that'll give us whether we're currently on the blue boundary or the red square. And now we can use a helper function to draw this. So video draw pixel x, y, and if draw square is set, we will use this red color, AA for red, 0 for G, and 0 for B. Or we'll use 0 for red, 5 for G, and BB for B. Hope that makes sense to you. This is just a color, which the FF is the alpha component of it, which you don't really need to worry about right now. So now at the end of this, when we're done with it, let's get the number of ticks there are now and figure out how long does this actually take to draw the screen. And we're just going to reuse that little resolution character string. Draw took this many milliseconds, and then I'll also include seconds, so it'll be ms end minus ms start and ms end minus ms start divided by 1,000. Alright, I think that's about it. So now we're going to draw that string. I'm going to put it at 2040, so it's just under that previous string. Let's see, try to think what we have to do here. Let's just say done. We'll print this to the console so we can see stuff's going on the console. And I'm going to sleep another 2 seconds to give you time to read that little message. And so now we need to implement a couple of those other helper functions. We'll start with the draw pixel, I think. So void video draw pixel. It's going to do a X, a Y, and a color. So we want to draw this color at that X and Y. So now to implement this, actually we need to do the volatile U8 pointer frame buffer. So this is going to be our actual buffer in memory. I'm using volatile so it doesn't get what do you call optimized out for some reason. Now this is a little bit of a magic numbers here. I can't remember how I actually found this out, but it was about a year or so ago I found out once you get this base, you have to OR it with this number and AND it with the complement, I think it is, of that number there. I'll try to see if I can find where I got those numbers from, but it's been so long that I can't remember. If I do, I'll put some details in the description. Alright, so now I'm going to pull the red color out of that color. So I'm just taking this first high byte, I guess you'd call it, shift it over by 24. Take the green byte, which is FF0000, shift that over by 16. If you don't understand this, let me know. We have I have a what is that called, Discord channel, which there's quite a few people in now, so I'm sure you can get help there on understanding this kind of stuff if you don't. Now I'll take the alpha channel. Alright, let's see. So now what we want to do, let's see if actually we want to get the pixel offset. And actually I already got that, didn't I? Oh yeah, I put it up here. It doesn't belong up here actually. Take that out. That's before I had a helper function for this. So down here, and yeah, it shouldn't be RQ, it should be frame buffer RQ. Alright, so now if the depth is 32 bits, so I'm really only going to show 32 bits for now, but I'll put some code in so you can see like a 16-bit color as well. But for this video, just to keep it not too long, I'll just focus on the 32-bit. Yeah, actually put that stuff up there, because we're only splitting the colors like this for 32-bit. So now I want to draw by setting the frame buffer pixel, that pixel offset, to blue first. And notice I'm plussing the pixel offset each time. Blue, green, red, and then alpha. Because it's 4 bytes for each color, or yeah, for each pixel. So otherwise I'm going to just use like a 16-bit color. I'm not actually going to test this. You can play around. Let me know if it doesn't work. Just shifting the top byte of that color over, grabbing it, and then getting the bottom byte of that color. And I think that's all we need. Yeah, because we're essentially drawing that color to this X and Y coordinate inside the frame buffer memory chunk. Alright, so now there's a couple other little functions we gotta create. Say video, draw character, draw this character at that position. For this one, we need to, let's see, loop through. Alright, so we're going to start it with y is 0 until y is the font height, y++, and we'll do the same thing for x. X is less than the font get width, x++. Yes equals font get pixel cxy. So it's going to get, I'm saying yes because it's basically saying, is there a pixel on the font at this point? Otherwise it's the background. So I'll draw it like so. Video draw pixel at pos x plus y plus y. If yes is set, I'll use text color, otherwise back color. And we'll actually need to define those. Text color and back color. That should be text color. We'll just do white for the text color, so all F's essentially. For back color, we'll use that same shade of blue, 55BBFF. And now we want to draw a string. So let's see. So we'll start with void video draw string. Take in the char pointer. Pos x, pos y. And so this one we're going to loop through each index. So we're going to loop from I is 0 to SI is not null, essentially. That's what not 0 for. And we want to increase the pos x by font get width. +2. Yeah, we'll add a little spacer between each of the characters. Now for each of these, let's see, we want to essentially just draw the character, right? So we have our video draw char function, so we can just make a use of that. So it should be video draw char, or car, however you want to say it. And which character we want to draw? We want to draw S at index I. And where do we want to draw it? We want to draw it at, okay, so yeah, position X, because we are incrementing that position X, so that will be correct. And then the position Y should be just as is, yeah, so position X and position Y. Alright, is that all of them? I think that's all of them. So now we can go over into our kernel. Let's see, kernel.c. I'll just leave all this stuff in here, I guess. Maybe I'll comment out some of these timer sleeps, because we don't need to pause to see these things anymore. And let's see. That sleep in there. We'll do it right after this first get max temperature. So do video, and let's see, printf resolution. The first one I'll do a fairly big one, 1824 by 984. And I'll just call video set res. Is it not showing up? Oh, I need to put video.h up here. Video set resolution 1824 by 984 by 32. So I'm going to copy this, and I'll do a couple different resolutions so we can see how they kind of perform against each other and how they look on the monitor. So after this one we'll do 1024 by 768. That's a pretty popular, smaller one. We'll do 1900 by 1200. That's a pretty big one. So 1900, 1200. And we'll do a really small one here. Yeah, like 480 by, was it 320? I think that's like an NES if I remember, or something I used to program in a while. So yeah, it's a really small size there. Let's see if we can build this thing. Make clean and make. And something messed up. Defined reference. Font get high. Yep, right there. Just forgot the T. Make. Alright, and before we go back to that, there's a bug I found here. In video drawstring, yeah, we're incrementing the position, but we also need to increment the I. Otherwise, we're going to sit there in that loop forever. So, alright. Now let's make. Still have some weirdness in here. Font get height. So let me. I don't know why that's showing up. Alright, I'll try to fix a couple things here. This mailbox FB request shouldn't be there. I think it's complaining about that. And we'll say return true. This is a bool. So return true. I don't think we actually need that to be a boolean. Let me see, is there anything else that came up? Video drop pixel, why can't it find that? Is that not in our header? Let's look. Video drop pixel, where is that called? So video drop pixel, it's right there. Is in our video.h. No, it's not. Okay, we'll put it in there. Let me grab the full name for that. Let's see, copy that. Also, yeah, let's change this to void while we're at it. It just doesn't need to be a bool. Okay. And back to our video.h, paste this in here. Do another build. Oh, video set resolution, void. Oh, I forgot to change the definition for it, or the declaration for it. There you go. I should have planned this a little bit better, but alright, it's building now. I'm going to ignore this for now. Now that it's building, I'm just going to kind of jump forward here and actually run it. And you'll have to excuse my shaky hand here. I'm going to show a little picture of it, but I should have a better setup for showing the monitor, which I will soon. But here you can see we got the resolution 1824 by 984. Now look how long it's taking to actually draw all those pixels. It's quite a long time. Alright, so that one. Let's do the next one is 1024 by 768. We'll try to zoom it out. It took 5 seconds. This is 1900 by 1200. This one's really chugging because we're essentially drawing each pixel one at a time to that location of memory, which plots it on the frame buffer. 16 seconds to do that. The smallest one here, that was quick, but still 1 second, which is essentially one frame per second. Nobody wants to do 1 frame per second UI. So how do we fix that? Well, one way to start is to use something called DMA. That's direct memory access. So instead of us writing code that interacts to move pixel by pixel, we say, here DMA, take this chunk of memory and map it over here to this device. So, and that's what we'll do in the next video, and you'll see that'll make things a lot faster. Not I don't think that's how they actually do it in the Linux kernel. They probably use the GPU, but unfortunately a lot of that stuff is just it's not open source. It's all closed source. But I think for a frame buffer at least, it should be good enough for us to make some kind of real world use out of it. So this one was just an introductory to show you how to start using frame buffers and drawing pixels. In that next video, we'll get on to DMA and make things a lot quicker. So I hope you enjoyed this video and learned something from it. If you did, please share it, like, comment, subscribe, and join our Discord channel, our Discord server. I'll put a link to that in the description as well. So thanks again for watching.